Hello everyone, welcome to a demonstration of the siPlanning for Everything 3D E3D tool by Sikla. For this demonstration, I am using E3D version 3.1.8, but the tool is and does support older versions of E3D, but we have recently reduced the support for PDMS. That's not to say if you are running PDMS projects that we can't help you, so please reach out. But the tool is now geared up to fully support E3D, newest versions, and unified engineering. I am running version 2026.1 of the plugin. And what does that mean? That means that is the first release of 2026. Sikla aim to update the plugin twice yearly. So that is March and October, the first release being the 0.1 iteration in March and a second release in October, with all the latest and greatest additions, and any hotfixes that need to be updated will be added to in interim releases. So you may see a 2026.1.2, for example, like that. So let's start with a demonstration of a typical workflow. It's worth mentioning that there are lots of tools and features within the plugin that are that will really benefit the user. However, we're going to just cover the basics today. Let's start with a secondary pipe support. What I'm running here is an example project, of course, which just has some slabs, some columns, some piping, all built within the E3D environment. However, we do support any IFCs in terms of still using the AI fixation aid, which can be demonstrated in another video. Of course, with everything in E3D, we need to keep our world structure in order. And what I'm going to design is a secondary pipe support in Sikla siFramo, and this requires a strew. So let's jump into it. So let's use the template designer. Okay, so left click on that tool. Once installed, we will see a new tab within your interface in the model space within E3D. At the moment, there is no current element selected, so our tools for parametric modeling are not active, they're inactive. So let's use the plus tool to create a support framework. The name given is indicative. This can be changed within the Sikla project manager settings within Paragon. For example, we have a lot of users that require the KKS naming convention for supports. That is an option within the project manager settings. But let's just run with what we have out of the box, which is a SU support 01. It's the first one we're modeling today. Now I have a framework to add support still 2. I'm going to choose a goalpost. Okay, and once left clicked, I get the prompt to pick somewhere within my model twice. So I could use a soffit, slab, or a concrete wall. I'm just going to use the slab in this instance. Left click once, left click twice. Anywhere, it doesn't have to be accurate to produce a model. You can see we're a little off here. So what I'm going to do is, first of all, you can see that the profile I selected was for the entire design was F100. Let's do that again so it's more clear. So we'll load the model, we'll delete what we've designed. Yes, I do want to delete that. Okay, so let's say we do that whole system again if it was too fast for you. I'm adding a framework, okay, and these tools become active. Now, before I click a template, I can choose the general profile to be used. We've got all sorts of channel profile, Framo 80, Framo 8030, all the siFramo products, and our new symmetrics profile. Let's say I want to use Framo 80 in this instance, okay? So for my base template. And that will be everything within this design will be made from Framo 80. I'll choose the goalpost and again click left once, maybe twice. I can make this a little bit wider, okay, with my clicks. The clicks determine the width of the frame, but it can be easily modeled. You can see I'm slightly off in where I clicked. This is not a problem. You can use your command line if you're that way inclined to move the tool as well. So let's just say by south, let's just 500. And the tool will move. But equally, within the template itself, you can see we have some parametric data now, including a move construction tool. If I hover over anything within the template, I get some highlighting, and including in the move construction part of the tool, some arrows to say where we will move to. So I want to move in this direction. Okay, so I'm left clicking there. 500 is the out of the box increment of measure, which maybe is a bit too much. So let's say I want to just go 300 and then enter to accept. I can also move using the coordinate system as well, just below. Let's accept on 300 by pressing enter and my frame moves. And again, I can do this in the command line if need be. Okay, I'm fairly happy with that as a base to work with. And it's worth noting that already you can see the intelligence within the plugin. Because I clicked slab, you can see that the Sikla plugin has added 4 anchors for the base plate, which is required. Okay, and the crossbar height was placed around the piping, although the piping is not associated yet with the frame. Let's make this a little bit wider. You can see the cuts are a little bit too specific. Let's make this 1500 wide. Okay, enter. And the frame will widen from both ends because I can lock either end if I wanted to stretch from one end or the other, but these degrees of freedom were left open. So yeah, let's just go with that as a base. We can manipulate lots of things within this tool. So as you can see, I'm wandering over with my mouse over the columns, and which column will be highlighted in the user interface. The parts that are used to build the frame are shown within the drop-down. Okay, so let's see at the base of this column, if you use the drop-down here, you can see that I'm using the WBD, the Von Bodendecker, the base plate end connection of Sikla, plus a profile. But maybe I want to change that to something else, which we can do later on. And in the same as the crossbar, the left side and right side use this standard Sikla components. I may want to change this maybe to the E-type for a different connection. Yeah. Let's just put that back to the base for the time being. Okay. What I'll do also, we had F80 as the out of the box profile used. Maybe I want the columns to be a larger profile, perhaps, to prevent some deflection. I'll change the left one to Framo 100 and the other side to Framo 100 as well. Okay, you can see they both have increased in size, and crucially, the connection used in both sides is now the reducing 100 to 80 because the standard connection is not suitable here. Base plate is not wide enough, so we need the reducing connection, which is intelligently selected already. Now I'll draw your attention to some of the red text that's appeared at the bottom of the screen. Okay, this is a live, on the fly advisory tool. What do I mean by that? Well, I have selected an F100 profile using a WBD. Okay, but Sikla also sell welded beam brackets. And what does that mean? So the base plate can be supplied off the shelf with either a 400 long, 800 long, or a 1200 long column. And this is an advisory comment to say you may want to reduce the number of screws and the speed of build, and increase the speed of build by using this beam section. Okay, let's do that. Let's change this end connection to a Traeger consoler. Excuse my German. With anchors. Okay. Excuse me, I used the left side. Okay. And I see that I have the same, one of the errors has disappeared because it's suggesting it for both columns. Okay. Let's do that for the other side as well. It's worth noting that the only tools, Sikla parts that are selectable are those that are compatible, okay, with each other, not the whole catalog. You can see that suggested warning has now disappeared because comforting is to read everything is apparently correct. Okay. If I were to change these tools back, these parts back to what they were, which was these two parts here, you'll see the screws find their way back into the model and the beam sections are replaced and the warning or advisory comment here appears. We can also interrogate some of these warnings and errors further using the consistency check tool. Okay, and a consistency check tool should be used throughout the design process. These live checks should be noted, and the consistency check should also be used to ensure that what the designer is building is realistically feasible to fabricate or build. There is inherent intelligence within the plugin, but there is also it's a piece of software at the end of the day, and so to ensure everything is compatible and correct, we have the consistency check tool. Now, at the moment, I haven't checked anything, but I do want to check the current CE, and you'll see that this is a mimic of what the errors, warnings we see down here. It's important that I clarify the difference between an error and a warning. A warning can be disregarded. It is an advisory comment that will perhaps improve the design. Okay, and it's the same warning we have. However, a failure or an error will impede the build of the frame. There may be a physical clash somewhere. Okay, good. I'm going to leave these on there for now, and maybe let's change one just to say that we can create differences in frames. It's worth mentioning that if you do create a template or a typical design that you want to save, we can export this typical and pull it through later as a out of the box template for you and your designers. Okay, perhaps maybe we want this cut here to be even longer. Let's just say this one needs to be 1500. Okay. Or we can chop them right back using the cut tool if need be as well. Okay. We can change the cut length. That is my advice to you, is rather than the base, the overall length, that is from underside of base plate to top of column and crossbars, for example, use the cuts to create uniform cuts that make sense from a fabrication point of view. I'm just going to leave it like that for now. And what are we missing? So we're missing here some primary pipe supports. Okay. So this is where I can draw your attention to the attachment designer. At the moment, I don't have any attachments on my frame, just a secondary support steel and pipes floating above it. Within the attachment design, there are lots of different variables. What I will do in the first instance is apply one of Sikla's adjustable pipe shoes, the Simatec pipe shoes. Okay, and I want it to be a floating pipe shoe, so unrestrained. Right. I'm going to use this button here, which is create a new attachment. Create attachment. So where do I want it? Okay, I would like that, please, to be this on this pipe. You can see the pipe shoe has been modeled instantly. And the second click is going to connect that pipe shoe to the frame. You can see it moves in place. And I'll turn off the design mode. So it's worth mentioning this is a 2-inch pipe, so the parts that have been provided are a 2-inch pipe shoe. But within the drop-down, if we would like some variables of this pipe shoe that Sikla provide, perhaps we want a double clamp solution. Yeah, we can use the drop-down to do that for us. Okay. Perhaps I would like the support to be guided. It's a very hot pipe with thermal expansion. I can provide a guide bracket or a fixed point bracket if we want to have a fixed point here. Any information or more product training is required, please reach out to me if some of these parts are unfamiliar. But at this point, I think if you're using the tool, you have probably had or received some knowledge of Sikla prior. Okay, that's one way. And if I now navigate back to the template design, you can see that the attachments have been linked to the template. Okay. In the same way, if I move my crossbar down now to say from a 790 top of steel from slab to 750, you can see that the pipe shoe extends. Okay. Or changes to the next size up because we have 3 off-the-shelf heights of these pipe shoes. What I would also draw your attention to is a brilliant new feature since version 7.5 of the plugin, so the end of last year. If I were to, let's just delete this attachment right now, okay, and use in the template design, you can see my attachments have disappeared because we don't have any. I will, this button here, the magnifying glass, I'm going to right click on here and say, okay, within the vicinity of my pipe support, or this crossbar specifically, because I've clicked on the magnifying glass on the crossbar, please add guided pipe shoes. Okay. You can see that instantaneously, regardless of the size of the pipe, an attachment has been added. And they've all got guides on. And then after this, we can manipulate any of these to something else. Okay, maybe I need the double pipe clamp plus a guide in this situation. Okay, or perhaps a pipe shoe. This may be just a cold pipe without the need for a Sikla pipe shoe and an industrial restraint. So maybe I could use what we call an assembly group. Yeah? And sorry, it's guided at the moment. I want this to be fixed. So let's say using not an M10, an M16 rod because of the static load. And these are more cost-effective options for pipes at DN 100 and under. Okay, not everything requires the industrial pipe shoe. This is an economization that we can offer. And we can, if you're interested what this part is, okay, let me draw your attention to, I'll close these template designers down right now, okay. Within the Sikla ribbon bar, we have the Sikla website, okay. If I enter that website, what parts have I used within this? If a designer wants to cross-reference these parts with the website, if, for example, or just find out anything about the design, just as bill of materials wise, we can enter the report mode, okay? What this is saying is, please make sure you have reviewed and resolved the errors or warnings within the consistency check, because of course we don't want to run bill of materials or extract drawings with errors. So yes, I have done that. And this can easily be locked behind a password if need be. At the moment, I'm in the report tool. Okay, I'm not reporting on anything because I don't have anything selected currently as an element. Let's say I want to run a report on support 01, and I'll add the current element. Now this could be done on batch if need be. I could do it at a zone level if there were more than one supports here, and it would populate every support within this strew or zone. I can remove supports easily using the same functions, okay? But let's just add this current element. And before I run my bill of materials, we are a German-based engineering firm, so the primary languages we have for the extraction would be English and German. We also have some options of millimeters, metric, imperial. And in this bill of materials, I want to see the primary attachments as well. So I've said, please include the pipe shoes and attachments. We can turn this off if we just want to see the secondary steelwork. There are some other options that I won't cover right now. But let's just see on screen what this this frame looks like. Okay. So we have all of the parts that are required to build this frame. Yeah. If I needed to check any of these parts, let's say I wasn't familiar with what GPL is, a 192900, which is the base plate here. Okay. I can put this, a 192900, into the Sikla website, which is linked directly from the plugin. 192900. Hit return, and this is the product, and you can find out about any of the features within this product, okay? Which is useful. This is just worth mentioning that this is a temporary extraction of the bill of materials. As soon as I close this, it is gone. I can extract this to an Excel file, which we'll do a little later on. Okay. Move that. So great. Now I'm happy with this design in this demonstration. Let's just say this. Okay. Maybe, in fact, for an example, I wanted to add something else to it before I move on. So you can see within framework 1, I have sub framework, and this is the template. Okay, but let's say I wanted to add another template to this design. I'll open my template designer. Okay, and within the same framework, I would like to add a different element to it. So I'm just going to add a cantilever. So a cantilever. Where do I want to connect my cantilever? The plugin asks. Just around here. Okay. And you can see that now I have another sub assembly and a new template. They are all owned and sit within support 1, but now we have 1, 2 sub assemblies. Okay. Editable as need be, just like the other tool. Maybe I would like this to be made from Framo 8030. Yeah. And you can see I need to rotate this. Let's rotate that so it fits the right way around, for example. Oh, excuse me, this is an F100 upright, so that is not going to work. Okay, so we don't have a reducing part from F100 to F80 in 8030. So there are two solutions here that we can do. I could either turn this back to F80, and you can see this component part would work. But let's change this column to F100 instead. So what I'll do would be navigate back to this subassembly, click the load button, okay, and load in my column. Change this part back to F80, okay, and everything shrinks back down. Now, left clicking on this part and loading will get the template up for the cantilever. Now you can see that I can reduce down to 8030 because there is a compatible component part. It would probably be more usable in the other orientation. So let's rotate that and say we wanted to connect a pipe shoe from here. Let's try and do that. Let's use the attachment designer. Let's click this part, okay, and link it to this crossbar. Now, this may not be completely practical, but what we've done is just rotated the pipe shoe to the crossbar above. And I think the cantilever looks a little bit long as well, but you can see this now, the primary, i.e. the pipe shoe, is owned by this template now rather than the goalpost. Okay, I'm just going to chop this back a little bit to 750. Yeah, everything is grand. It's worth saying then that if I ran a bill of materials on the top level support, that everything will be owned within the support one. Let's say I'm quite happy with that now, and this is where some of the tools really come into their own. So let's say I would like to copy this assembly or this design. What wants to be copied? Well, I've navigated to support one, so let's say the current element. And again, we have a silhouette appear before I accept the move. I'm going to move this every 2 meters, for example, through the east axis. You can see we're going to travel east along the pipeline. I have the option to just move the steelwork or the steelwork and piping. So I'll choose this button on the right rather than the one on the left. Click. Okay. What follows is just the results of the copy saying this is successful, and I can even go again. Okay, and so on and so forth to reproduce this. Of course, I can rename these supports because they've just taken the a shadow of what was being copied, and I can, of course, rename this to whatever need be. Let's say support 3. Okay, and similarly for this one, support 2. Okay, that could have been done in the copy tool as well, if need be. So we have 3 identical supports which we're happy with. And now if we want to run another extraction of bill of materials, let's run a report, okay? Make sure our errors are being addressed. Now if I add at the top level the support, okay? Within this support there'll be, sorry, let's remove that. Let's go to the strew level and add this everything. You can see all 3 supports are added in the list. If I didn't want to see number 2, for example, I could just remove number 2, or remove everything, or add everything. Okay. Instead of on screen this time, I want to create a file. I want to extract this to an Excel or an export. This is where the file will be found or saved. So let's create this file using the same settings as before. I'm using version 2026.1. So the template that is supplied with the plugin looks just like this. So the extraction we see, we have a totalized bill of materials. So everything within those 3 supports in a list is in this first tab. The second tab has everything listed as per the name structures, which you can again filter if need be. So support 1 items all the way down to there, so on and so forth. The pipe supports, these are just the primary material, i.e. the pipe clips and pipe shoes. Cuts lists are, just as the tab suggests, any cut items, including threaded robs of the primary. Okay. Total cut length, this is a totalized list of all the cuts, regardless of what frame they belong to. Support list, so these are the supports listed and connected to. Okay. Each frame. So you can see in support 1, we have 3 pipes, the DN100 and DN50 and DN80. These are the names of the pipes here, which can be useful. A pipe report, again, something similar here to the last tab regarding specifically the piping rather than the attachments. And any checks. So this is important to see that we have run the report, but there still remains some warnings, which are acceptable, okay? This is for Sikla and yourselves to review to ensure that when I do a bill of materials or an extraction, that there are no failures or errors, okay? Great. Let me close this down. Now, Finally, what I'd like to show you just in this demonstration is the extraction of a drawing. No, in fact, actually, let's do something very quickly to say that it is not only piping that is able to be supported. We can have some containment and electrical services or ducting. So let's build a new support on this column here. Okay. Let's close this down and add in a new cantilever, for example, using the template designer. I want to add a new support, and you can see number 4 would be the next in line in the list. I want to use this button here, a cantilever. Okay, so let's click onto this column. It's just given an arbitrary length of 800, but you can see that is probably not long enough for what we want to pick up. So let's make this 2 meters long, which is arguably a very long cantilever. So let's upgrade this to the larger Framo 100 profile. Are you sure you want to change that? Yes, I do. Okay. And what I just wanted to demonstrate is, let's just move this down a little bit for the demo. Let's move this down 150. That at the moment I have nothing linked to this design. It's just a secondary pipe support. And you can see the on-the-fly designer said 2005 is an unexpected cut. That's not that usable. So let's change this to 2 meters. I will add in some attachments. Okay, so in the attachment designer, I'll go into design mode. Okay, and regardless of the settings here, the plugin recognizes that I'm going to click on a ladder and some ducting. So I'll say design. I want to click on the ladder and link it to this. I want to click on the cable tray to here, the ducting to here as well. Okay. Now, if I go back to my template, you can see those 3 things have been linked to my cantilever. But the pipe clearance, because I moved it down, is too high. Of course, these things don't have any upstands. So let's create a clearance of 0. And the pipe frame, pipe support will be now right directly underneath of those containment. Okay, let's turn off my designer and get rid of that. I mean, that looks a little bit under-designed right now. So what I can do within the same support 4 is add a brace. So let's say, where do I want my brace? I want it to be from the siFramo to the column. And it's put an arbitrary brace of that length. The angles, the strongest type of brace we want, let's go 45, 45. So that is the angle of the brace, okay? Right. And let's use some of the features within the tool to correct some of those misalignments we had. I just used that repair button there to make sure that after the change of angle, that everything was great. Okay, very easy, very simple. And it's worth noting, you can see that the primaries are owned by the first template because we have 2 templates here. We have the brace as one parametric template and the crossbar. Okay, so you can see if I load again the cantilever, that the attachments are associated with that, but within the same support. Good. What I will do is let's use the power of this tool to show you how to extract a drawing very easily. Okay. Let's say I want to run just one drawing. I would like to open up the drawing generator, which as of the newer versions of the plugin is featured within the model part of E3D rather than draw. You can go into draw and do the same and the tools will be reflected there. But there is, it was recognized that jumping from one to the other, it might be time saving to have some of the draw tools within the model space. So let's click on drawing generator. And as you can see, we have a drawing generator tool within the model. At the moment, we don't have anything to create a drawing for, so let's decide to use Sikla Support 01, this first frame we have here. We choose the CE current element, and there are some parameters here that can be modified. For example, within this first tab, we can choose what we want to use as a key plan origin, so maybe a site coordinate system, grid line, should I say. I won't cover all the variables here, and just generally try to use the out-of-the-box settings. So within the General Settings tab, this is where we can add backing sheets. We can change the size of the backing sheet. All the typical things you might see within the Draw module of E3D. We can change the coordinate system from east, north, up to X, Y, Z. We can choose whether to display building elements within the volume of our drawing. We can choose the language selection of the bill of materials, what units of measure we're going to choose, whether we want to include the list of piping that we may see, or cable trays, or the primaries within the drawing. And also whether to include drawing revisions. I haven't showed you that, but let's just do that now if need be. So within Support 1, if I were to use Revision Manager and open up this tool, currently we have no revisions, but if we want to lock in a set revision for this, let's put in my design initials, and we want to say the revision is going to be issued at issue for construction. We can create a revision. At the moment, the first revision is default as 0, but again in the parameters of Project Manager, we can set this to alphanumeric revisions, then leading into numeric if need be. So internal design revisions can be A, B, C, D if need be. These are just out of the box settings. Okay. Now, you can see that this support itself has a new subframe, which is just for the revision. Okay, and this will be reflected in the output of our drawing generator. So if I click drawing generator again, and within the general settings, we have revisions turned on. Within the view settings, this is a bit more specific about what can be seen and what will be labeled within the typical 4 views that we see within the drawing itself. So this is to be read as a column. So view 1 is turned on. The type of orthographic projection is a front, and within view 1 we will show dimension lines only in view 1, not in the other 3 views. The type of dimension style can be governed here. I'm going to use a compact dimension style and nothing else but dimensions in view 1. But in view 2, we want to see some coordinates. View 3, which is a plan view of you looking down, we want to show some building coordinates and a north arrow. And view 4 is where we want to show the parts list line labels, so on and so forth. And again, the key plan, we're going to reference that from the demo grid. If we're happy with these settings, and they can be changed, you should note that whatever is changed is saved upon exit. So if you want to keep a set of variables, you don't have to change them each time. They'll just remember from previous selection. Now let's go ahead and press draw selected. Okay. And remember, we're just running one drawing, which is support 01, but this can be run for a batch of drawings. And this may take longer than one drawing, understandably, for the system to process, but it can be run overnight or something like that in a batch process. And once this is complete, you see some flickering going on here, that the Draw Explorer is active. I'm just going to close down the drawing generator template, and you can see the the design that we produced is out of the box, essentially ready to be printed. Okay. You can see the revision I added in at Rev 0 IFC was by myself on today's date. The border is an indicative Sikla border we can load in your own templates. We have our key plan that's referenced to the grid line. We have in view 4, so this was 1, 2, 3, 4. In 4, we have the parts list, which is relevant to the top right of the drawing. So let's say item number 12. If we look at the part list here, is the beam section cut at 1500 mil. And as previously said, we can change some variables here. So it's typical to see that any primaries would be alphanumeric instead of numbers. This is just settings that need to be manipulated. Totalized weight of the frame, individual component weight, and then totalized weight of each component. For example, we have a beam bracket, which is, no, let's look at another item. Let's say a multiple. Yeah, I mean, we have 8 resin anchors weighing 0.13 kilograms, so the totalized weight is just 1 kilogram, for example. And there we have it, guys. This is a demonstration, or has been a demonstration, of the siPlanning for E3D plugin. There are various settings and customizational options and tools that we haven't covered today. For example, within piping, we can add alternate inlays. Within the Model Explorer, we can have different anchors as opposed to then those out the box. There are various drawing parameter settings that can be manipulated, but I think this is a good starter for anyone that needs a tutorial. Please do reach out if you need a more thorough training session. But thank you very much for your time, and thank you very much for listening, guys.